Hey everybody, Cole here with Classic Mini DIY, and on today's episode I have something super exciting and really unique for you guys. We are going to be replacing the entire timing system on my Classic Mini's engine, the Turbo Bad Wolf engine. We are going to be replacing it with a Kent Auto Developments, that's KAD, belt drive kit. I'm so excited about this, you guys. It's going to be a lot of fun. You won't want to miss it. All right, everybody, welcome to the next episode of Classic Mini DIY. I am so excited about this. I've been wanting to do this for a long time on my Mini, but I haven't found the belt drive kit that really met the needs of my engine and what I wanted out of a timing system replacement until now. And full disclosure, Kent Auto Developments actually sent me this kit. They are a sponsor of this Resto-Mod mini build, and as a result, they have sent me this belt drive kit free of charge. Now, even though they've done that, I'm gonna do my best to provide you guys an impartial review of this setup here and give you guys my impressions of installing this, why you might want to or not want to do something like this on your car, and all the intricacies that come with it. In addition, we also got one of their Kent Auto Development CNC'd oil pumps. These are really great. This is a race oil pump, so it's going to be good for really high RPM, but it is an exceptional setup for any engine. I believe they now sell a road version of this oil pump too. So jump over to my desk. I'm going to show you guys exactly what comes in this kit and talk about that a little bit more. Now, for those of you who might be unfamiliar with a Classic Mini timing system, the original setup was a simplex, that's one single set of teeth, simplex timing gear, and that gear had a chain on it. Now, that is a great system. It works the way it needs to work, it's very reliable, and there have been improvements to it over the years, specifically moving to what's called a duplex setup, that is 2 rows of chain, and that adds some structure, some safety, and some strength. And then there are all sorts of variations on it where we have steel and aluminum, and fully alloy setups to change the weight and the total amount of load that is on your timing system. So what about the KAD belt drive system? Well, this setup is a little bit different. You guys may have seen belt drive systems. MED makes one. There is another company, I think SwiftTune makes one, SC something. There are a few different options out there, but this one's unique in that the belt drive system is fully exposed and there's no enclosure that this belt drive sits in. Now that might scare some people, but a lot of modern cars drive and run with exposed belts. This is kind of like pretty normal stuff. It's not that unusual. This belt right here is a HTD 480 belt. This is something called Power Grip. It's made in the UK, but it is an exceptionally strong belt. This is a motorsport belt. It's not like, you know, the belt that you wear around your waist. Now, why would you want to change to a belt drive system? Well, there's a few reasons that I want to change to it, but more broadly speaking, the belt drive systems tend to be a little bit quieter, and overall they are lighter. There's less metal, there's less things required in order to make it run, and they hold their timing really, really well. And you get a little bit finer adjustment with this. Now, this has what's called a vernier gear. This has multiple screws in it and allows you to change the timing by a degree, a few degrees here, a few degrees there, and then that allows you to set your camshaft timing. I've done a video on this, which should be popping up in the corner if you're not sure what that is, but we're going to be doing that again in this video, and there's some nuances around this belt drive system that are, worth mentioning. Now, why did I want a belt drive system? Well, I mentioned this as I was tearing down my engine, or in one of my previous videos, that the engine setup that I had, specifically the pulley that comes out of the bottom where it connects to the crankshaft, has always leaked. On literally every engine build I have done, I have tried every trick in the book. That is centralizing this plate before tightening it down, centralizing it on the pulley, I have tried products that you wrap around the face of the pulley that are supposed to help fix that seal. That has not worked either. So I wanted to move to something that is a dry system that removes the oil from that timing system and keeps it in the engine compartment. The way that this works is this belt drive plate right here. This is CNC'd, it's beautiful, has a nice little oil galleyway on the back. This mounts in the place of your original timing plate, back plate. And then the pulley system with the belt drive actually sits on the outside, and that's fully exposed and accessible. Then you have your tensioner that gets installed to tension your belt, and everything kind of goes together the same way that a timing gear would. But the reason I wanted this, in addition to that leak protection, is that it's way more serviceable for me with the engine still in the car. The Mark I has a built-in radiator shroud, and it makes it incredibly difficult to service anything on that side of the engine when the engine's in the car. So doing any sort of timing work down the road is going to be very difficult for me. Removing that radiator, getting the room you need, let me assure you guys, it is absolutely miserable. So my goal here is to increase the serviceability, make this a little bit easier to access, reduce the amount of leaks that I have, all while upgrading to a really nice, reliable setup. Now, some people ask, how frequently do you have to change these belts? And like with all things, it depends on how you drive your car, how often you drive your car. So I am going to install this on my car. I'm going to show you guys how to do that. Now, for those of you who are curious about what skill level is required to do something like this install is a little bit closer to expert or upper advanced level. When installing timing gears on your car, there are simple ones you can get where you have a little dot to align, your timing and have a base, and then you can degree your cam from there. This kit does not come with that. This is effectively setting your timing in what I'm describing as hard mode, and it's very important that these get timed correctly, otherwise your engine will not have a good time. And if you are doing this, I would recommend getting a Haynes manual because there are some illustrations in there that are going to be really useful. So let's jump over to the engine. There are a few things I need to prep before this stuff goes in, namely the lifters and the camshaft have to go in, and then we can start assembling the rest of this stuff. All right, so now we get to the fun part, and this is something I have shared in previous videos. It's actually an enormous pet peeve of mine, but KAD, I don't know what it is about the United Kingdom and the people who are selling stuff over there, but every single time I order from a parts supplier there, they do not include these gaskets with the kit. Like, you're obviously replacing these things as part of this whole setup, and yet you don't include those in your kit. Drives me crazy, but it's fine. It's fine. It's fine. Luckily, I had these in stock. And then next, we are going to go ahead and install our timing plate cover here. Now, the way I'd recommend bolting this in is loosely setting all of these screws in place in each of these holes, and this kit doesn't come with lock washers, anything like that, so you're definitely going to want to put thread locker on here. Put thread locker on every bolt. It is going to save you, it's going to give you some peace of mind, but it's also going to help you if you ever have to take it apart. So we're going to go ahead and put some thread locker on each one of these and run them all in. Now, as you're putting this in, you'll notice these two screw holes down here underneath the crankshaft. These are the shorter of the two smaller bolts. It's important that these are the smaller ones because the back side of these is actually kind of like a gasket interference location. And if you don't use the shorter ones here, you are going to bottom them out and then you won't be able to get your gearbox on. So just something to keep in mind. Next up, we are going to install our camshaft retaining plate. Now, one thing you might notice, and actually let me change the camera so you can see this. Now, looking at this from a slightly different angle, there you'll notice a hole right down here. And this plate is going to go over this. The whole purpose of this right here is to retain the oil inside this chamber here. And that hole allows the oil, this is the bottom right here, allows the oil to go down, run behind this and down into the crankshaft space and allow it to return to where it needs to go. That is any oil that does get up here. But this is where it gets a little confusing. So this plate is going to go on right here like so. Just going to get that in place. And then this plate goes on top. Now it's a little confusing, but the reason they do this is because there's a rubber seal here, and you can use all the same mounting bolts for your camshaft, but it's just a little bit longer and allows it to sit down in place there nice and tidy. It's really, really a nice setup. I'm blown away by just how well thought out this is, even though it didn't come with gaskets. So next up, what we're going to be doing is installing the pulleys and the belt drive system itself. So first we start off with this crankshaft pulley, and you'll see me here. What I'm doing is I'm actually using my main pulley and damper system to pull that actual belt drive pulley down into place. It was a little fiddly. It wasn't exactly hard to pull in there, but it didn't want to move all the way down towards the crank and level itself out. Now next we're going to be installing the tensioner itself. So there's a process for doing this. Essentially you get that little lock nut to run that post down a little bit, and then you put the tensioner itself on and fully tighten this down. Now this is going to spin that post and also work this down into the block. This is the point at which it kind of starts to tighten up, and then I went ahead and loosened it a little bit so that I could then rotate that tensioner to test out how to tension the belt itself. You can see there are 3 holes on that tensioner. Now unfortunately I lost the footage, my camera cut out while I was putting this pulley on, but essentially it's the same process as putting the crank pulley on. The only difference is that it has a capped nut on the top side of the crank. So what we do here is tighten that down pretty strong with like hand tight. You can see the pulley itself that surrounds it is loose. I don't have that tightened just yet. After you've got that hand tight, if you took these bolts out, now is the time to put those back in so that you can tighten this down. It's going to allow you to torque this actual nut that's on the camshaft to the necessary spec. Now, I took these out so that I can inspect everything to see how it all goes together. But once this is installed, once you get those bolts back installed, then you're going to be able to torque this to specification. After you've gotten those tightened down, the next step is to install the belt itself so that you can torque this down. You can see I'm tensioning the belt, and then I am adding my pulley on the end of the crankshaft here so that I have a point to hold on to while I torque the cam nut itself. So that gets tightened down, I torque the camshaft itself, and then you're ready to go. So now we're going to move on to what I think is the hardest part of this whole build, or at least when you are doing any sort of precision camshaft work like we are here, is getting the engine timed. Now with this setup, like I mentioned earlier, there are no dots to indicate whether or not you have what is effectively the base timing. And so that's what I was talking about. This is kind of like timing something on hard mode. Now, the easiest way to do this is, you can see I put a little mark right here for the Woodruff key or the keyway on the camshaft, and then of course you have your keyway on the crankshaft here. That's going to indicate top dead center on your crank, and then this is going to indicate just at least where that keyway is on your camshaft. Now the reason I did this is because you can see here in the Haynes manual, they give you a little orientation guide to where those Woodruff keys should be. You can see that the crankshaft is perfectly at top dead center, and then you can see of course that the camshaft's at about 2 o'clock. So this is what I'm going to use as a rough guide to at least get those 2 pulleys in a rough orientation. And then we are going to go through the steps of degreeing the cam. I did a whole video on this a while back, and there was actually a misspeak in that video, so I'm going to cover how to degree this again in this video. Now, starting off, I have you guys looking right face on with this, and you can see this is already pretty much at top dead center, and then this I'm going to orientate to about 2 o'clock. Now, this is not exactly right. This is not the exact static timing location, but it's going to be good enough to get us started. Now, once we have that set up, we're going to need to move to the top of the engine block, and I'm going to show you guys how to find exactly top dead center. And we're also going to need to add a little indicator marker so we can measure where these things are. All right, so now that we have this oriented at about 2 o'clock and this one pointed upwards for top dead center, we're going to go ahead and install the cam belt. Now, we want to do this in a way that is going to avoid rotating any of this. But the reason that we need to get this installed is so that we can accurately set the cam timing and they will actually impact each other. Beautiful. Now we have that installed. Let's go ahead and add some tension to this so that the belt doesn't move anywhere. So now we have tension on that. We have our belt installed, and the next step is to zero out top dead center for our dial gauge. So let's go ahead and get our dial gauge on here so you can see what I'm talking about. All right, so this next step is where it might get a little bit confusing, but essentially what we're doing is finding top dead center using the piston at the top here. The way I like to do that is by placing my dial indicator. I like these digital ones because they're a little bit, more reliable. But essentially, you're going to set this right in the middle of the piston here, and then you'll want to zero out this dial indicator, and then you're going to rotate the engine until you find the point of hesitation. So you can see that the piston is going down there, and then when we rotate it the other way, it'll go up to about 0, and then it'll go back down again. Now, the goal here is to find that point of hesitation and then zero out your dial indicator. Almost. So it looks like right there is top dead center for me. We can zero that out. And then you'll want to move back over to your dial gauge. And then you'll notice your degree wheel here has got a bunch of varying degrees on it, but we are going to point this right at 0 degrees to indicate we are currently at top dead center. Now you want that to line up. Some people like the thing to go over the degree wheel. Some people, like me, like it on the edge. And this is what we're going to use as our base measurement point to get the actual degree of lift. So I find this is where people seem to get a little confused, but what we're going to be doing is measuring the cam lobe. It's shaped like a lobe, and you'll have a leading edge and a trailing edge, but then you'll have the top of that cam lobe. Same way we set the 0 point of top dead center here, we're going to use the intake valve, which is the second hole as seen from this side of the engine, second hole on the back here. We're going to move our dial indicator up onto this lifter. And then when this is in place, we're going to do effectively the same thing. We are going to find that point of hesitation. When the lifter is going up on its compression stroke, it'll find a point of hesitation and then come back down. So the way that we do this, I'm going to go ahead and zero this out. And actually, before we do, I need to rotate this down just a little bit so it's level. Like that. Go ahead and zero that puppy out. Beautiful. So now we'll rotate it one way a little bit. And it looks like I positioned that a little too low. So we're going to have to move this up a little. There we go. Gotta allow it the full amount of travel. All right, so 3.96 is our highest number. Go ahead and zero that out again. Now this is the top point of our hesitation. And so this is effectively the top of our compression stroke. Now, this might feel confusing, and the first time you go through something like this, it can be really confusing. So essentially what we're gonna be doing is rotating the engine about 0.5 degrees one direction, 0.5 degrees the other direction from this hesitation point. So 0, and then rotate the engine left, and then 0, and rotate the engine right. And then we're gonna take 2 figures off of our degree wheel and do a little bit of math. So let's rotate this. 0, 5. There we go. All right, and with it 0.05 that direction, we are going to take this measurement. So it looks like we have 135 degrees. Go ahead and write that number down. And then with that measurement, we're gonna rotate back the other direction, 0.05 millimeters again. There we go. And now we should have another measurement. And it looks like we have 119, maybe 118. We'll go with 119. Now this is where the math comes in. We are going to want to add 135 and 119, and then we're going to divide that by 2, and that is going to be our degree of advance, which in my case is 127 degrees. Now in my case, I need to retard my cam so that it is not so advanced. 127 degrees is definitely way too much. And the way that we do that is by loosening the 4 bolts on that cam wheel, which unfortunately with my degree wheel here, it does require me to take this off. We're gonna have to reset and zero out everything again and then redo our math. I'm not gonna bore you guys with going through that again, but what we can do with this cam belt setup is very cool. We can adjust this cam by loosening those bolts and rotating it just a little bit. So let's get this degree wheel off. We're gonna adjust this a little bit and then remeasure everything. All right, so now we have this puppy fully timed. It took about 9 variations of me adjusting this back and forth to get to our perfect timing figure, but we finally got it there at 108 degrees. So the last thing that I did, and I did this off camera, but I actually marked where the pulley belt is on this pulley system. You can see my paint in there. I don't think that's actually gonna last. So what I did was with this in time, I counted how many teeth were between 2 arbitrary points on this pulley. So you have a little dot right here, and I actually made this dot with a small punch, and I made one right over here. There are 22 teeth between these 2 dots, which I can use in the future to easily adjust and set this timing again and put a new belt on when it is time to replace it. This is one method. The other method that OEMs use, which I was taught by a friend of mine, was to have a mark on the pulley cover. So have it on maybe the back plate and align those dots with the back plate and then slide your belt on. I'm doing this now because I won't be able to get access to this in the future, and I want it to be serviceable and easy to manage in the future. Now, one other thing I do want to mention is that each of these bolts has Loctite applied to it. It's very important that that gets Loctited so those don't come loose. And then this tensioner tensions that belt. You should have had that tensioned while you were setting the timing. It made it a little bit easier, made sure the belt didn't flop around. But all that's left now is to install my actual pulley for my management wheel, and I think I'm gonna go ahead and install the cylinder head. So let me show you guys how I'm gonna install this pulley. Now, while dry fitting this pulley, I actually just found out that this little screw has what I assume was where it was mounted on the lathe. I'm guessing this little notch right here is sticking out and actually bumps into my MED timing pulley that I have, which is this one right here. This is the management wheel with the missing tooth, and these teeth contact that when it's screwed in. So I'm gonna cut this little tab off here, and then we'll be able to put that pulley on. All right, now with that removed, we can go ahead and install our pulley here. This is just a simple MED pulley, which also already has its top dead center mark and everything on it. Gotta find that keyway. And should just go right on. There we go. Oh yeah, now that clears perfectly. All right, so in my setup, obviously I'm kind of mixing brands here. And so this MED pulley is one I already had, and I'm really happy with it, aside from the fact that it really didn't hold up to weather very well. That's not ideal. But otherwise, the pulley itself is really nice. And I have all of my crank position sensor stuff already set up with this, so it saves me a lot of time. KAD also sells their own damper pulley with a sensor bracket. It mounts down here, and it's extremely nice. Like, there's no doubt about it. That is a very nice setup. For me, I have a special setup with the front intercooler from the car kitchen, and I have a sensor bracket that's associated with that. Now, one thing I was noticing while I was test fitting this is, unfortunately, my bracket doesn't fit perfectly. I'm gonna have to do some cutting right here, maybe clearance it out to there or something. We'll see. I think I can make this still fit. It's unfortunate because I did powder coat it already, so it means I'm gonna have to redo that. But it'll be worth it to make sure that fits nice. Plus, this little bracket thing that I got going on here is embarrassingly bad, along with the rest of my welds. So don't look too close at that. All right, and with that, I think I'm gonna wrap up this episode of Classic Mini DIY. I don't wanna spend too much time on building the engine. We've done that in other episodes, and I'll cover more of that when we get to that stage. But I have to tell you guys, I'm so excited to see how this belt drive performs. I'm curious to see how long the belt lasts as well. From what I was reading about this belt on the manufacturer's website, it says that it's good for about 60 to 105,000 miles. Now, it depends obviously on how the car is driven, how the engine is run. If you're running the car at higher RPMs, a lot of the time you're probably going to need to replace it closer to 60. But if you are babying it, it probably can last kind of in the middle of that range. I'll probably target changing it around 60,000 miles or about every 5 years. Obviously, we're going to want to make sure that we're taking a look at it, inspecting it, and making sure that it's not got any frays or anything like that as the years go on. But I want to say a huge shout out and thank you to KAD for sending me over this kit. I'm super excited about that. I really appreciate them supporting the build. And if you guys have any questions about this kit that I can help you out with, feel free to post those in the comment section below, or head over to their website and pick one up for yourself. Now, the next episode of Classic Mini DIY is going to probably be more engine building, or at least something related to that. We have a lot more in store, a lot of really cool custom stuff that we are going to be building and setting up on the new shell when it comes back from paint. So you won't want to miss that. Make sure you stay tuned for it. And until I see you guys on the next episode, you know the drill. Enjoy those minis and motor on. See you guys.